Hello, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 4 of Intermediate R. Now all of the material is here at chriswoods.com/intermediate-r, and we're now looking at the function section. Now it's likely that a lot of the R code in the vignettes you saw in the last page did not make much sense to you now. Now do not worry, you are new to R and are still near the beginning of your learning journey. Now over the last half of this workshop we will explore some of the building blocks of R, so that then the vignettes will begin to make a little bit more sense to you. Now a core building block of all programming languages is a function. A function is a reusable block of code that can be used over and over again in your program. Now a function takes inputs, which we call arguments, and it then does something to those inputs to produce some outputs, which are returned to you. Now you've already used many functions, so for example, when we typed library stringer, we were using the library function. This was a function which loads the library, passed here as the argument, the first thing we passed in. Now notice that we call a function by using round brackets. So we use the name of the function, round bracket, and then the argument that we're going to be passing in when we call the function, close round bracket. We have another argument here, another function here. This is str_length. Str_length here is taken in hello, and it will return the length of the string. Here we have the function cat. Cat will print whatever it is passed, and here we're printing the result of sprintf, which is another function which basically takes in the arguments, the first being the formatted string, and then the variables that will then be substituted into the format string. So if we just type these in, first function was library, which is bringing in the stringer package. Then let's now create the string hello R. Now we're going to call the function str_length. So we have the name of the function, round bracket, and then the argument that we're passing in close round bracket, and this function will now calculate the length of the string and return it to the variable length. Indeed, if we now cat length, you'll see the length is 7. There are 7 characters in that string. We can then use the cat function. We can pass into the cat function the sprintf function, to which we will then pass in a format string, %s, has %d characters, new line, and then it was going to be the hello string, and then the length of the string that we calculated. And there we are, we've now called the sprintf function to format a string, which is then passed as the input to the cat function, which then prints the string to the screen. Now, as well as being able to use functions, you can write your own functions in R. And indeed, this is really powerful because it lets you package together your code so you can do your things that you want. So let's imagine now we're going to try and write a function that calculates the mean average of a list of functions. So there are many ways that we could write this function, and let's try and do this. This is the solution I would come from. Now the first thing we do is we say what's the name of the function. So this is going to be, in this case, calculate mean. And indeed the name of the function is just a variable into which we will assign the function itself. Now we define a function by using the function keyword, and the function keyword basically says this is going to be a function that we create. You then specify the arguments that this function will take. In this case, I'm going to create a function which just has one argument, which we're calling values, and so this is a one argument function. Next, you open your curly brackets, and now if I do shift return, that will now enable me to go to the new line. So now I'm going to write the body of the function. So these are the things that each function will do when we call it. So first, I will set a total variable from 0.0. Sorry, and I hit return. You should always remember when you're doing this, and I always make this mistake as I'm going. Shift return when you're inside the curly brackets. Count we're assigned to variable 0, shift return, and then we've been passed in here values, which we're going to assume is a list of values. So we'll say for value in values, remembering the for loop that we did last time. Shift return here. We will update the total to be the total plus the value in this list, and then we'll update the count to be count plus 1. So you can see here what we've done is we basically summed up the total of all of the values, and we've also counted them all up. Finally, the function needs to do one thing, and that's return the result of the calculation, and we return using the return keyword. So this is how we get the output from the function. So values was passed in, return passes something out. Now the mean is just the total over the count, so we type that, total divided by count. Now when I press return, what we've now done is we've defined this function which is assigned to the variable calculate mean. We can use the function just like we use any other function. So let's say, for example, now I'm going to create a new list called person heights. I'm going to assign to this the numbers 1.62, 1.80, so these are the heights in meters, 1.56, 1.73, and 1.91. The average height we can now get by calling our function calculate mean, which you can see here I'm calling in exactly the same way as before, calculate mean, and then we pass in person heights, hit return, and then we can then print out the answer, can't sprintf, the average height is %.2f meters \n, and then we pass in here average height. So you can see here the average height is 1.72 meters. So how did this work? What's the scaffolding of this function? Well, first we have the name of the function, which was here. This is the variable into which the data for the function has been passed. So in this case, calculate mean is the name of the function, and that's why when I do calculate mean passing in person heights, this is the function that gets performed. Now the function has one argument, which is values. So when I do calculate mean person heights, what happens is the person heights data is copied into this argument here, which is values. We then open curly brackets because everything between curly brackets makes up the body of the function. And so everything between these curly brackets is then run every time we call this function. So the input was values, that was passed in by copying in person heights. And then the output is given by return, which is total over count, which you can see is returned here to the variable we've called average height. Now the lines of code, what happened is because values is person heights, for value in values is thus for value in person heights, hence we're going to loop over these 5 bits of data, and as we loop through, we sum them up, we perform the count, and then we return here the total divided by the count, which is the mean. Now, this is described, as I said here, in the scaffolding. So there we had the variable that's being returned, the variable holding the function keyword, the arguments, and then here with the curly brackets, you place all of the code that should be run when you then call the function. The inputs are passed in, they're copied into this variable. So when we use this variable, it is basically the data of whatever argument has been passed in. So in this case, this was our person heights. And then at the end, we then return, and that returns an output, which is then placed back into average height, which has been returned. This means in general, the way that functions work is you first call the function that you've created. In this case, I calculate mean, round bracket. You then pass in your inputs as arguments, and you can have as many arguments as you wish. In this case, we defined one argument, which was values. So person height is copied in as values. The function will then run. It will perform all of the code which is here. It will then return the output, which is assigned back to the variable which is holding the result of your function. Now what I would like you to do as an exercise is you've now seen calculate mean. I'd like you to create a similar function called calculate max. This should return the largest value that you have in the list of arguments. So as a hint, you should create a variable called max value and set that equal to NA. You remember NA means not available. And then you can use the if is NA max value or value is more than max value as a test to see whether each value is going to be greater than the one you're holding as max. And note here that this double sort of pipe symbol, and you'll find that on your keyboard somewhere in the bottom left or bottom right, this means or. So if it is NA or the value is greater, that means that we have a new value which you should be holding as max. So with that, press pause, and when you come back, I'll then show you the answer. Okay, you've now unpaused, so I'm going to try and show you the answer now. So I'm going to press Control L again just to clear this screen. And I'm actually going to make this a little bit bigger just so we can see things. There we are. So calculate max. So we first say what the name of the function is. So calculate max, and that's going to be assigned from the function keyword. We pass in the name that we're going to use for the arguments and then number. In this case, this will be just one argument. We then open curly brackets, and the first thing we need to do is have a max value which we assign from NA. Now we have our values, which will be whatever has been passed into this function. So we can say for value in values. And as we said before, if max value is NA, then this is the first value and we do want it. So we can say if is.na max value, that means we must be on the first value, or any subsequent value is greater than max value. That means we found a new value which is greater, so we do want to keep this. We can then say that max value equals value, was assigned from value, sorry. Now what this will mean, went down, come back. Oh, I'll just type that again just to be clear. So calculate max. So be very careful when you use up arrow and down arrow when you're teaching, otherwise you lose what you just typed. So again, curly bracket opened, max value assigned from NA, then for value in values, open curly bracket, if is.na max value, or value is greater than max value, open curly bracket, max value is assigned from value. Okay, then you shift return. We've now managed in this loop to basically loop through and find the largest value within the values. The final part of the function is where you return that result. So in this case, we just need to return max value. Now when I press return, that's now saved this function. I can now create my person heights, assign that from 1.62, 1.80, 1.56, 1.73, 1.91. And now I can say max height is assigned from calling my function, which is calculate max, on person heights. That's now been called. And then if we print that cat sprintf, the highest person is %.2f meters. And let's do max height as the variable we pass in, and now when we press return, we can see the highest person is 1.91, which we can see makes sense based on the values that we passed in. Now, this function works well, and our calculate mean function worked well, but what would happen if we put the wrong arguments in? So for example, let's say we're going to take a result, and someone's going to try and calculate the mean. So calculate mean, but instead of passing in numbers, they're going to pass in strings. They're going to pass in cat, dog, and horse. Now if we now try and run this, we can see that R has given us an error. It's not actually run the code at all. And the error is total plus value non-numeric argument to binary operator. Now this is not very descriptive or helpful. You'd want to basically give your user a function a bit more information as to why something has gone wrong. Now one way to give more information is to use the stop function. So let's go back to our definition of, there we are, calculate mean. Where am I? That's it. So this is the function that was called. I've used the up arrow to refind it. Now the reason that it couldn't work is because this total plus value assumed that value was numeric. So what we want is we want to give a check to see is the value numeric, and we can do that using an if function. So we can say if not is numeric value, open curly bracket. This is now said the number is not numeric, so is numeric is false. Is numeric is false for things which are not numeric. So if not false is true, which means if a non-numeric value comes in here, then we will execute the code in this if block. We can now use the stop function, and what stop will do is it will stop executing the program, and we can basically pass in an error message now which makes more sense. So let's say stop cannot calculate average of non-numeric values. And if I now hit return, that's now updated our definition of calculate mean. And now when I try and run calculate mean again, we can now see we have an error in calculate mean, cannot calculate average of non-numeric values, and the result is not run. Now this is good. It means we can give useful error messages back to our users of our functions. But let's say, for example, instead of stopping, we want to have the function keep going and only try and calculate the average for numbers which are numbers. So basically ignoring numbers which are basically strings or not NAs or anything like that. Now we can do that by basically doing a test, and instead of using stop, we should just use warning, and warning will be used to give a warning to a user that some of their input has been ignored. So let's now go back to our calculate mean, and now let's think here. So we've now tested if not is numeric number. We can say stop, but what I now want to do is I'm going to change this around a bit. So I'm going to just take all of this out. There we are. I'm going to say first, try and get the number as a numeric. So number as numeric value. Now what this will do is it will try and turn our value into a number using as numeric. And if it fails, it will return NA for not available. So then in our if statement, we can say if not is NA number. So this means if it's not an NA, so this is a number, we can then update the total from the total plus number. We can update the count from count plus 1, and everything is fine. But let's now use an else statement to then give a warning to the user. So if we do warning, let's tell them we are skipping value as it is not numeric. And then we don't need to run it. So this means now we're only going to be updating the count and the total if we have real numbers in here. Hit return, it's now been defined. If I now try to calculate the average of cat, dog and horse, we can see now we've got NAs introduced by coercion, skipping cat as it is not numeric, and indeed you notice I've got no spaces here. I'm just going to update my function just to put some spaces in, just so it's cleaner. There we are. They are skipping dog as it's not numeric, skipping cat as it's not numeric. But let's now try and use something where we have cat 10 5 dog. We can still see we've now got the average of 10 and 5, which is 7.5, because it only skipped cat and dog. It still did the calculation for 10 and 5. So this now brings us down to the last exercise in this section. What I'd like you to do is I want you to do a similar set of error catching for your calculate max function. I would like you to print warnings when non-numeric values are skipped, and I want you to stop when there is no maximum value. So for example, when somebody has passed in just strings, and so we must stop now because there is no maximum from a set of just strings. Press pause, and when you come back from pause, I will show you the answer. Okay, you've now come back from pause, so I'm going to show you the answer. So first I will Control and L and clear my screen, and I will go back up through my history by pressing the up key to where I could find the calculate max. So here this is. So the first thing we're going to do is try and coerce this value into a number. So I'm just going to remove this section. Okay, and I'm now going to make number assigned from as numeric value. First thing we're going to say is this not a number? So if this is not a number, so it is a number, that means this wasn't a numeric value. So I'll print a warning to the screen. So warning, ignoring, space, value, comma, as it is not a number. Okay, and then we'll do an else block. With the else block, we'll then use the same test that we had before. So if is.na max value, or value is greater than max value, that means we found a new maximum value. Sorry, always make the mistake when I hit return. There we are. We can then say max value equal is a sign from value. Now finally, we want to add a stop in if we don't find a maximum value. Now when we don't find a maximum value, it means that we never update max value to a number, and that means it will still be NA. So we can test if is.na max value. That means we haven't found a maximum value, so we'll stop the program. You can only find the maximum of numbers. And that will stop, and then nothing will be returned. So we can then only return something if we actually have a maximum to return. I've now set the function, so let's now calculate max of dog, cat, and 5. So this should return 5. There we are, we got the value 5 out, and it printed warnings that dog is not a number, cat is not a number. However, if we try and print something without a maximum, in the case here, we got a stop. You can only find the maximum number of numbers, you can't find it from anything else. There's a hard error there, in addition to the warnings that were printed. Okay, so that's finished the last exercise of this section, so that means we've now completed part 4. In part 5 we'll move on to data frames, and we'll begin looking at reading and working with some data. So I look forward to seeing you in part 5.